All right, let's jump right into this. Welcome to the Explainer. Today, we've got a highly targeted session built specifically for one single purpose, helping you absolutely crush your upcoming railway exams. We're diving deep into the high-yield source material on switch rail grinding machine, or SRGM, track grinding procedures, and quality inspection metrics. Now, if you're prepping for these exams, you already know the deal. The operational manuals are dense, they're super technical, and they are literally packed with numbers you simply cannot afford to forget. So, my goal today is to systematically break down this source document and build a visual mental framework for you. We're going to lock in those strict operational rules and the exact metrics you need to memorize. So get ready to take some notes and let's get started. Here's our game plan for today. First, test site selection rules. Second, 3-part testing zones. Third, essential quality check metrics. Fourth, SRGM preparatory works. And finally, number 5, block working and safety.
Section 1. Test Site Selection Rules. Let's dive right into our first major exam bucket, which covers the very strict criteria for selecting a quality inspection test site. You can't just pick any random stretch of track for this. The rules are incredibly specific.
Exam writers absolutely love to trick you on these specifics, so pay very close attention to the numbers. First, distance. A single test site represents a 20 to 50 kilometer stretch of track. Also, you've got to have entirely separate test sites if you're dealing with different track structures, like say 52 kilogram versus 60 kilogram tracks. The site also has to be easily accessible by road, so measuring instruments can actually be brought in. And here is a massive red flag for multiple choice questions. You must never, ever select a site where the rail is slated for renewal within the next 3 to 4 years. Lastly, the site just needs to be a typical representation of the track. Regular signals, normal level crossings, standard traffic speeds, the whole shebang.
Section 2. 3-part testing zones. Okay, so once you've successfully chosen your test site based on those strict rules, the site itself is divided up into a highly specific layout. To conquer this section on your exam, just use the rule of 3. This layout spans exactly 3 sleeper intervals. Zone 1 is designated for the MINIPROF instrument, usually marked as MP, which measures the rail profile deviation before and after the grind. Zone 2 is dedicated strictly to photographing the contact band right on the rail surface. And Zone 3, that is set up exclusively for the die penetration test, or DPT. Let's actually look a little closer at how Zones 2 and 3 function.
You absolutely need to know the distinct difference in methodology here. The contact band is tested by chalking or painting the rail surface and then passing a goods train right over it. Think of it kind of like taking a literal fingerprint of the steel wheel's actual footprint within a specific bandwidth on the railhead. It proves the rail wheel contact point is perfectly optimized after grinding. The die penetration test, on the other hand, is completely different. It relies on applying chemical dyes that seep down to reveal the exact number and length of microscopic surface cracks. Comparing those DPT photos before and after grinding definitively proves whether or not the grinding pass was actually effective.
Section 3. Essential quality check metrics. All right, sharpen those pencils, because we are entering an absolute goldmine for multiple choice questions. We're talking about the exact numerical metrics that define a successful grind. Honestly, if you only memorize one section today, it needs to be this one. First up, memorize this exact number, 12. Specifically, 12 microns. To put that into perspective, a single strand of human hair is about 70 microns thick, so 12 microns is unimaginably fine. This is the absolute maximum allowable surface roughness on the rail after the SRGM has done its job. Anything rougher than 12 microns, that's an automatic fail. Next up is the number 80, and this relates to the Grinding Quality Index, or GQI. The GQI basically measures how close the post-grind rail is to a perfect target profile. Now, while a score of 100 represents a completely flawless, mathematically perfect profile, the real-world operational standard says that any score of 80 or above displayed on the GMDMS screen is strictly acceptable. Finally, we have 250. When you're measuring the track with a master gauge after the machine has passed through, the crown radius directly at the center of the railhead must be right around 250 millimeters. So, let's recap. 12 microns for roughness, 80 for minimum GQI, and 250 millimeters for the crown radius. Burn those into your memory. Now, when examining the actual marks left behind by the grinding wheel, which we call the grinding facets, you really need to know the contrast between a good and bad finish. A good finish features very regular marks with clear silver-like spots. Conversely, if you see bluing defects, that's bad news.
That indicates thermal damage from improper grinding. And crucially for your exam, you need to know the perfect facet width. It should be roughly 10 millimeters dead at the center of the rail and exactly 4 millimeters out at the corners.
Section 4. SRGM Preparatory Works. Long before the switch rail grinding machine even touches the track, there's a strict 11-point preparatory checklist from the source manual that you've got to be super familiar with.
We've split this checklist up to prevent cognitive overload. On the physical logistics side, highlight this requirement. Stabling facilities absolutely must be arranged specifically every 50 kilometers. You also need to identify railway consumer depots, or RCDs, to ensure a timely diesel supply. You've got to arrange an adequate water supply, and you must pre-plan adequate traffic blocks so the machine has completely uninterrupted time to actually do the work.
Now for data and track prep. Operators have to feed all the curve, level crossing, and joint data into the GDMS software and study the track's flaw history. But for exam purposes, the biggest takeaway here is knowing exactly what to skip. Operators must intentionally skip grinding on any sections with severe corrosion, deep liner bites, or any stretches of track that are already planned for renewal within the year. Grinding those specific sections is literally just considered a total waste of machine life and resources.
Section 5. Block Working and Safety. Let's move into our final section, which details the strict block operating procedures and the absolutely non-negotiable safety rules. Safety is huge in railway operations, and exam questions are heavily weighted toward this.
So how does the workflow actually play out? Before starting, that mini profile reading has to be done. Once the block actually begins, the machine's chainage must be perfectly synchronized with the track's real-world chainage. Furthermore, and this is key, operators have to secure enough block authority to complete exactly 3 grinding passes. It takes 3 complete passes to fully grind the railhead, right? So planning a block that only allows for 1 or 2 passes is just considered a failure in planning. I am heavily emphasizing this one because it's a critical zero-tolerance safety rule that shows up all the time on exams, usually as a true or false scenario. It is strictly prohibited to cross under the SRGM during operation or when any work is ongoing. Literally no exceptions whatsoever.
Let's be real. Rail grinding is essentially just grinding away solid steel. It creates intense heat, flying sparks, and crazy amounts of fine iron dust. So all staff have to wear full PPE, helmets, goggles, reflective jackets, the works. Staff and gatemen need to be kept far away from the machine. The climbing ladders have to be completely free of grease, oil, or fuel to prevent slips. And finally, because of all those flying sparks, every single onboard fire suppression system, the water pumps, the water cannons, the ditch sprays, they all absolutely must be completely functional to instantly put out any dry tie or grass fires.
Okay, let's lock this in right now before we wrap up. Answer this question in your head. What is the minimum acceptable GQI score, and what are the target facet widths for both the center and the corners of the rail? Think about it for a second. If you instantly remembered a minimum GQI of 80, a 10 millimeter facet right at the center, and a 4 millimeter facet out at the corners, you are totally prepared to ace this section of your exam. But I do want to leave you with this one final thought. Passing the exam is really just day 1. Right? When you're out there on the actual tracks at 2 in the morning, relying on these exact numbers to keep thousands of tons of steel moving safely, will you just trust the numbers, or will you trust your own eyes? Good luck with your studying, and we'll catch you on the next explainer.